All right, strap in, everyone, because today we are going deep into computer vision, where machines are learning to see just like we do.
Right.
And we've got some incredible research to dig into.
Yeah, yeah.
So our goal today is to give you a solid understanding of how this technology
Right.
is changing everything,
Yeah.
from self-driving cars
Mm.
to even healthcare
Yeah, that's right.
and everything in between.
It's pretty remarkable how far it's come.
Yeah, for a long time, computer vision was kind of stuck.
Absolutely.
It was using these really specialized solutions.
Yeah, yeah.
And it seems like with deep learning, things have just exploded.
Oh, absolutely. It's been a complete game changer.
So these algorithms can now spot patterns and details
Yeah.
that would take us forever to find.
Yeah, it's really incredible.
But before we get too far ahead of ourselves,
Right.
let's start with the fundamentals.
Absolutely. The building blocks.
What are the basic tasks of computer vision?
So the most basic is image classification, which is, we teach computers to recognize these broad categories in images,
Okay.
like cats and dogs and birds.
So it's basically like sorting photos into labeled folders,
Yeah, exactly.
but on a massive scale.
Right, exactly, on a scale that we couldn't possibly do ourselves.
And this is where we see convolutional neural networks, or CNNs, coming in, right?
Yeah, CNNs are really the heart of a lot of this image processing these days.
I've heard they're kind of the superstars.
They really are.
How do they actually work?
Well, they're designed to kind of mimic
Okay.
the way our own brains process visual information.
Okay.
So they start with simple edges and textures,
Okay.
and then they build up to more complex shapes and patterns.
So they're not just matching pixels, they're actually
know.
understanding the structure of what they're seeing,
That's right. They're learning to understand the underlying visual structure.
which is pretty amazing.
Yeah, it is.
But classifying an image is one thing. What about finding specific objects within that image?
So that's where object detection comes in.
Okay.
And object detection goes beyond just labeling the whole image.
Okay.
It actually pinpoints the location of each object,
Uh,
often by drawing bounding boxes around them.
it's like when your phone camera highlights all the people and objects it sees.
Right, that's a great example.
Yeah.
And this is super important for things like self-driving cars.
Right, because they need to know where everything is.
Absolutely. They need to be able to identify pedestrians, other vehicles,
Yeah.
traffic signs, all in real time.
Now, I know there are different ways to approach object detection.
Yeah, there are a couple of main approaches.
Could you break those down for us?
Sure. So we have region-based CNNs,
Okay.
which are very thorough,
Okay.
but they can be a bit slower
Huh.
because they look at each potential object region one by one.
Oh, yeah?
And then we have single-shot detectors like YOLO,
Okay.
and those are all about speed. They try to detect everything in a single pass over the image.
So it's a trade-off, basically,
Yeah.
between accuracy and speed.
It really depends on the application.
Okay, that makes sense.
Now, let's move beyond just identifying and locating objects.
Okay.
Image segmentation takes things to a whole new level
Right.
by dividing the image into these meaningful regions.
So instead of just boxes around objects,
Right.
we're talking about like the outline of every object.
Exactly, outlining every object and background element in detail.
Wow, that's a lot of detail.
It is, and it's really important for things like medical imaging.
Right, where you need to be very precise.
Exactly, like if you're trying to segment organs or tumors.
Yeah, the stakes are a lot higher there.
Absolutely.
Now, are there different types of image segmentation?
There are, yeah.
Can you talk about those?
So we have semantic segmentation,
Okay.
which labels every single pixel
Yeah.
with its category.
Uh-huh.
So think road, sky, car.
So it's like a color-coded map
Exactly.
of what everything is.
Right.
Like that analogy.
And then we have instant segmentation,
Okay.
which goes a step further and separates individual instances
Right.
of the same object.
Okay.
So instead of just labeling all the people,
Right.
it can pick out each person individually.
So semantic is about the what.
Yeah.
And instance is about the who.
Exactly.
Okay, that's a good way to remember it.
And how these techniques work.
Yeah, how do they actually do that?
There are traditional methods that analyze the pixel values using things like edge detection,
Uh-huh.
but the real game changer has been deep learning models.
Deep learning again.
Yeah, it's popping up everywhere, right?
It really is.
Things like UNet and Mask RCNN.
Okay.
These models can learn these incredibly complex patterns
Yeah.
and give us much more accurate segmentation results.
It's amazing how deep learning is kind of this common thread
It really is.
through all of these different tasks.
It's sort of revolutionizing the entire field.
Yeah, but we've been talking about broad categories
Right.
and objects in general.
Mm-hmm.
What about recognizing specific things?
So that brings us to image recognition,
Okay.
which focuses on identifying unique individuals or objects,
Okay.
like facial recognition on your phone
Right.
or systems that can identify specific car models.
So not just knowing it's a dog,
Right.
but knowing it's your dog.
Exactly.
A Fido.
Yeah, that's a great way to put it.
So for a long time, this relied on feature extraction techniques
Uh-huh.
like SIFT and SRF,
Exactly.
which were designed to pinpoint those unique features.
Right. To find those distinctive elements that make something unique.
So it's like finding the fingerprint of a face or a car.
Yeah, that's a good analogy.
But I'm guessing deep learning has found its way into this too.
Absolutely.
How is deep learning used in image recognition?
Well, deep learning models, particularly Siamese networks
Okay.
and triplet loss, have become really powerful for this.
Yeah.
They can learn these subtle differences between images, even when they're hard for us to see.
So they're like super detectives,
Yeah.
uncovering the tiniest details.
Exactly. And this has huge implications for security, personalization, even medical diagnostics.
It's incredible how these techniques are blurring the lines
Yeah, it really is.
between what humans and machines can do.
It's pushing the boundaries of what we thought was possible.
But we've only scratched the surface.
Yeah, absolutely.
There's a whole world of other tasks
Uh-huh.
that computer vision can tackle.
Yeah, and we're going to dive into those in just a bit.
We'll be back with part 2.
So stay tuned.
And we'll uncover even more mind-blowing capabilities of computer vision.
It's going to be a wild ride.
All right, see you soon.
See you then. So, welcome back to our deep dive into computer vision.
I'm excited to hear what else is out there.
We've covered the fundamentals, but now we're going to get into some really mind-bending stuff.
All right, let's hear it.
Okay, so first up, pose estimation.
O's estimation, okay.
This goes beyond just recognizing or locating objects.
Uh-huh.
It's about understanding their position
Okay.
and orientation in 3D space.
So like a computer being able to track
Exactly.
the movements of a dancer.
Yes, or an athlete.
Or an athlete.
So not just who they are, but
Right.
how they're moving in the world.
So where is this being used?
Well, you see it in sports analysis,
Okay.
where it can track players
Uh-huh.
and give insights into their technique.
Oh, that's cool.
It's also being used in healthcare
Okay.
for physical therapy and rehabilitation.
So helping patients recover.
Right, and
Yeah.
track their progress.
That's amazing.
It's really bridging the gap
Yeah.
between the digital and physical world.
Yeah, it really is.
How do they actually do this?
Yeah, what are the techniques?
There are a few different techniques.
Okay.
You know, you have traditional machine learning models,
Uh-huh.
and then depth learning uses things called heat maps,
Yeah.
which are these visual representations of the computer's confidence in its pose estimations.
So it's not just seeing a static image.
No.
It's analyzing movement,
Exactly.
understanding how things are moving.
Right, the dynamics of the body.
Fascinating.
Okay, ready for the next one?
Get me?
Text detection and recognition.
Okay, so computers are learning to read.
Yeah, pretty much.
That's incredible.
Yeah, it opens up a ton of possibilities.
What can we do with this?
Well, think about digitizing old documents.
Okay, yeah.
Making information accessible to people who can't see.
That's a really good point.
Or even automating tasks, like data entry from receipts.
Wow.
The potential is huge.
It really is.
So how do they do it?
Yeah, how does that work?
Traditionally, it involved techniques like sliding windows
Okay.
to find potential text regions,
Uh-huh.
and then character recognition algorithms to
Right.
figure out the actual text.
Yeah,
But deep learning is playing a role here, too.
I had a feeling you were going to say that.
Of course.
What are the deep learning models for text?
So models like EAST and CRNN
Okay.
are being used to read text from all sorts of sources.
Amazing.
It's really remarkable.
Deep learning is really the recurring theme here.
It really is. It's transforming everything.
So computers can see images.
Right.
They can read text.
Yeah.
What else can they do?
Well, let's talk about image captioning.
Image captioning. Okay.
This is where computer vision meets language.
So like giving a voice to the visual world.
Exactly.
What are the challenges with that?
Well, it needs a deep understanding of both visual and linguistic information.
So not just recognizing the objects,
Right.
but understanding their relationships
Yeah.
and what's happening.
Exactly. And then turning that into a description.
Okay, that sounds really difficult.
It is, but we're using techniques like RNNs,
Okay.
recurrent neural networks,
Uh-huh.
with attention mechanisms.
Right, to focus on the right parts of the image. Wow, so the computer is actually trying to tell a story.
Yeah, in a way.
That's incredible.
Now, let's move on to something crucial for robotics.
Okay.
Visual SLAM.
Visual SLAM, what's that?
It stands for simultaneous localization and mapping,
Okay.
and it allows robots and devices to map their surroundings
Okay.
and track their position
Okay.
using just visual information.
So like a built-in GPS.
Yes, but with cameras instead of satellites.
And this is essential for self-driving cars.
Absolutely.
Because they need to know where they are.
Right, and how to navigate.
Okay, so how does visual SLAM work?
There are two main approaches.
Okay.
Feature-based SLAM
Uh-huh.
and direct SLAM.
And what's the difference?
Feature-based SLAM uses distinctive features.
Like edges and corners.
Exactly.
Okay.
Direct SLAM works with pixel intensities.
So each approach has its own strengths
Yeah.
and weaknesses.
Depending on the environment.
This is all really mind-blowing.
I know, right?
We've gone from recognizing objects to reading text to understanding movement,
It's amazing how much is possible.
and now mapping the world.
And we're going to dive even deeper in the next part.
Okay, I can't wait. Welcome back, everyone.
It's been quite a journey.
We've seen some incredible things from recognizing objects to understanding movement to even mapping the world.
Yeah, computer vision is pretty amazing.
But now I want to get under the hood
Okay.
and see how it all works.
Let's do it.
What are the key techniques that make all of this possible?
Well, a good place to start is feature extraction.
Feature extraction, right? We've talked about that a little bit.
Yeah, it's kind of a fundamental concept.
Yeah.
It underpins a lot of what we've discussed.
So can you give us a more in-depth explanation?
Sure.
What exactly is feature extraction?
It's basically about identifying
Yeah.
the most important visual elements in an image.
Okay. The things that make an object unique.
Exactly. Those unique characteristics that help us distinguish things.
So it's like finding the visual fingerprints of an object.
Yeah, that's a great way to put it.
So edges, corners, texture.
Right. Shapes, patterns.
All those
like that.
things.
Exactly.
And for a long time, this was done with handcrafted algorithms.
Yeah. Engineers would design these algorithms to find specific visual cues.
Like SIFT and SR.
Exactly. Those are really powerful techniques.
But they had their limitations.
It did, and that's where deep learning comes in.
Deep learning strikes again.
It always does.
So how is deep learning used for feature extraction?
Well, instead of using pre-programmed algorithms, deep learning models, especially CNNs, learn to extract features automatically.
So the network is figuring out what's important on its own.
That's right. It learns from the data.
It's developing its own visual intuition.
You could say that.
That's incredible.
And this has led to some major improvements in accuracy and efficiency.
Across all sorts of tasks.
Yeah, pretty much everything.
And speaking of CNNs, we've mentioned them a lot.
They're kind of a big deal.
Can you explain a little bit more about how they work?
Sure. So imagine a series of filters passing over an image. Each filter is designed to detect specific patterns, like edges, curves, shapes. And as the image goes through these layers, the network builds up a representation of the image.
So it starts with simple features and then combines them to understand more complex things.
Yeah, it's a hierarchical approach.
Okay, that makes sense.
And that's why CNNs are so powerful.
Yeah.
They can capture both local details and global contexts.
So they see the whole picture.
Yeah, literally.
It's amazing how these networks learn.
I know. It's pretty mind-blowing.
And this brings us to deep learning.
Right, the big picture.
How does deep learning fit into all of this?
Well, deep learning is basically a type of machine learning that uses these artificial neural networks with many layers.
Hence the deep. And they learn from massive amounts of data.
Yeah, the more data, the better.
So it's like giving the network a crash course.
Yeah, you could say that.
In visual perception.
Right.
By showing it millions of images.
That's the basic idea.
And that's how they get so good.
Yeah, they're able to learn all these complex patterns.
But these deep learning models, they don't just process every pixel.
No.
They use something called attention mechanisms.
Yeah, we talked about those a bit with image captioning.
Can you remind us how those work?
Sure. So imagine you're looking at a busy street.
Okay.
You don't see everything at once.
Right.
Your attention goes to the important things.
Okay, like a car running a red light.
Exactly. Or someone about to cross the street.
So attention mechanisms allow the model to prioritize
Yeah.
the important parts of the image.
That's right. They help it focus.
Okay, so it's like giving the network a superpower.
Yeah, like laser focus.
But we need to remember, it's not all just about algorithms.
No, there are other things to consider.
What are some of those?
Well, data is crucial.
Right, data is king.
It is. These models need tons of labeled data.
Uh-huh.
The more data, the better they perform.
So it's not just about quantity,
Right.
but also quality?
Exactly, and diversity.
You need a good mix of data.
Absolutely.
And what about computational resources?
Yeah, these models need a lot of power.
Mm-hmm.
Training them requires serious computing power.
So you need the right hardware.
Absolutely.
And finally, how do we know if these models are any good?
That's where evaluation comes in.
Okay.
We need to measure their performance.
Using things like accuracy and precision.
Exactly. And recall F1 score.
All those metrics.
Right.
So it's not just about building a cool model.
No.
You have to prove that it works.
Exactly.
Wow, we've really gone deep into computer vision.
It's a fascinating field.
And it's only getting started.
That's what's so exciting.
Who knows what the future holds?
The possibilities are endless.
I think that's a great place to wrap things up.
I agree.
We've covered a lot of ground today.
We have.
But this is really just the beginning.
Yeah, there's so much more to explore.
So for our listeners who want to learn more,
there
are tons of resources out there.
Yeah, the internet is your friend.
You can dive into the ethics of facial recognition.
That's a big one.
The use of computer vision in art and design.
Right.
Or even explainable AI.
Lots of cool stuff to check out.
And as computer vision keeps evolving,
yeah,
it's going to have a huge impact on our lives.
Yeah, I have no doubt.
So keep those minds curious.
And your eyes open.
And who knows, maybe one day you'll be pushing the boundaries
You never know.
of this amazing field.
That's right.
That's all for today.
Thanks for joining us.
We'll see you on the next deep dive.
Until then.